Gene editing can help reverse damage from chronic overdrinking, at least in adolescence. That's pretty good news, obviously. If that's all you want from this information, you can just leave right now and tell your friends that gene editing can help reverse damage from chronic overdrinking, at least in adolescence. If you're interested in some of the how and whys and whats of this gene editing, strap on in and let's learn some vocab together. Hi, it's Ftrhstry. This is a time vortex from the next 100 years, and gene editing is the most exciting technology, well, arguably, I guess, other than AI for the 21st century. It's a lot of fun to learn about. There are lots of crenellations and offshoots to go run down and explore, and some of them are involved in this study. So let's just dive right in. We'll talk about the ARC gene, activity regulating cytoskeleton, and two other words like associated protein or something, because scientists don't know how acronyms work. Is an important gene for protein formation, which relates to long-term potentiation, potentially depression, and memory. It's critical, apparently, to synaptic plasticity, which makes sense because how your brain rewires relates directly to what kinds of things make it sad or anxious, and what kinds of things it can plan to do, and what its deep associations are with historic events. Right, so hence memory. So, what scientists did in this trial about drinking was they mostly were muddling with rat brains, but they have confirmed that in humans with chronic overdrinking in adolescence, the ARC gene can get damaged. So that's apparently not good. If the ARC gene gets damaged, for the rest of your life, you might have increased anxiety and increased susceptibility to over-consuming alcohol. These are quite common problems. You shouldn't feel ashamed of them at all if you're experiencing these. Many people do. And so the exciting bit of this science is that there may be some possibilities of reversing that damage and helping give people more options when it comes to whether to drink more, how anxious to feel, possibly how depressed to feel. We'll see where this goes in time. Well, you'll see, I know, because I'm from the 2120s. We do lots of gene regulation. It's kind of like updating software code for us. I mean, it's a bit of a tired metaphor, but it really is like that. It's tinkering with the source code of life. You're just in an earlier stage where you're figuring it all out. Now, you've probably heard of CRISPR-Cas9. You may not have heard of CRISPR-Cas9, which does something slightly different, and it's what scientists use in this study. Cas9 can bind to genetic material, and instead of slicing a gene, it can augment it, which allows for some interesting possibilities of basically like you can turn something on instead of just shutting it off. So they used CRISPR-Cas9 to sort of upregulate and downregulate ARC gene expression, and they did that by controlling acetylation and methylation. These are basically just chemical terms, more acetyls and more methyls, and acetylation upregulates chromatin, so it loosens the amount of chromatin in the system. Maybe it loosens how it behaves physically. I'm not quite clear on that. And methylation tightens chromatin. So when you loosen it, you allow transcription factors which relate to RNA, DNA interacting with RNA, so it can send messages to other parts of the body. And when you tighten chromatin, you inhibit these transcription factors, making it harder for the DNA to talk to the rest of the body through RNA. So allowing the transcription factors normalizes ARC gene expression, and inhibiting the transcription factors downregulates ARC gene expression. When you normalize ARC gene expression, you get less anxiety and less alcohol overuse. And when you downregulate ARC gene expression, you get more anxiety and more alcohol overuse, at least in the case of someone who had, at some point in their past, experienced over alcohol use. So that could lead to alcohol use disorder or anxiety later. So that's a lot of terms. Let's back up and just do them all again so that we get this vocab. They used CRISPR-Cas9 which instead of slicing genes, latches onto them and allows for an additional modification. And they did two basic things with this. They attached to the ARC gene and they tried acetylation and methylation to see what would happen. And in the case of acetylation, they loosened chromatin, which upregulated transcription factors, which apparently had the effect of reducing anxiety and reducing overindulgence in alcohol. Then on the methylation side, it tightened chromatin, which decreased transcription factors, limiting DNA's ability to talk to RNA, and that resulted in more anxiety and more alcohol overuse. Possibly this could relate to other problems like depression or even anger. This is the kind of thing that you're going to figure out as you go further into the future here. So DCAS9, that's a good one to take away. Acetylation and methylation-ish, interesting. Chromatin is interesting. It's basically what chromosomes that aren't in bacteria are made of. So chromosomes in eukaryotes, which is us and every other kind of living thing except bacteria, which it turns out is most living things. But for us eukaryotes, we've got chromatin, us in our chromosomes. And when you loosen it, you increase transcription factors, which is another important phrase. Transcription factors relate to DNA and RNA interfacing, DNA sending messages through RNA. When you tighten the chromatin, you reduce these transcription factors, which is bad. So loosening chromatin, increasing transcription factors, good. Tightening chromatin, decreasing transcription factors, bad. Okay, I think we've learned all this vocab now. Where is this going? In the next 10 years, you're going to learn a lot more about this. You're going to be able to reverse some significant damage, not just from drinking in adolescence, but from drinking later in life and from other kind of bad behaviors, other kinds of drugs, other kinds of brain damage that might be completely unrelated to substance use or not. And then in the 30s and 40s, you're going to learn more about how this stuff starts to relate to bigger emotional pictures. So like not just anxiety, but yeah, depression, anger, jealousy, curiosity, passion. Lots of this stuff, it turns out, because, you know, genes are the software, is related to genetic chemicals in your brain. So that's both really exciting and a bit of a head scratcher, because it opens up this wonderful door to a huge array of questions about like what you want to upregulate. What would you like humans to be more of? What would you like them to do less? And as an exercise, we should all ask that about ourselves. If we could wave a wand, what qualities might we want to increase and what might we want to edit down? That's just a good thing to do in life anyway, isn't it? We should all be iterating toward improved versions of ourselves. Thanks for going on this vocab journey with me. I learned a lot. I hope you did too. Here's to us all improving just a little bit tomorrow. See you then, or the day after, or whenever you would like. I'm always here. Love you. Future bye.